Okay, so my name is Inge Raknes. I'm a Master of Computer Science, and I work.
Sorry.
Okay. And I work as a programmer and engineer at University of Tromsø, and I've been working mostly on MetaPipe. I'm going to explain to you a bit about doing metagenomics in the cloud. I'm going to talk a bit about some of the challenges that we face building MetaPipe and how the cloud helps us solving those. So first of all, why do we need a cloud? So here is basically a traditional bioinformatics workflow. I mean, you download and install a piece of software and you run the tool, and then you get the results within a few hours. So why wouldn't you want to try and do this with MetaPipe on your laptop? Well, currently we have distributed MetaPipe onto 20 machines at University of Tromsø. With one of our example datasets, it has taken about 24 hours to annotate it. And if we try and do that, compare that with a regular MacBook Air, a very simple estimate, we get to about 3.5 months. Yes, you probably don't want to do that on your laptop, in other words. So the solution to this is to distribute the workload onto a cluster of machines. One of the challenges of this is that you probably need to use someone else's computer. And this in turns brings a few other challenges, like you don't have root or admin access, so you cannot just install software in the regular way. And then there is also someone else that are managing all the updates, so how do you know that the system that worked yesterday works today? And part of the solution to this is the cloud. It makes it easy to scale to get more machines. You can reproduce a setup that you have made working before, and it's a lot easier to deploy a pipeline to the cloud than it is to, for example, a traditional HPC system. So a few words about scalability. So as you can see, you can allocate a lot of machines. There is a screenshot from the CSE cloud, which will be used for running MetaPipe on this course. And here you can see pretty much how easy it is to just launch another instance on the CSE. So we can just create more machines when we need them. It's easy to reproduce machines that we have created before. You can take a snapshot of a virtual machine that works, you can clone it, and you can basically run it again later. And the best part, from my point of view as a programmer at least, is that everything can be automated. You can basically create a program that builds a server, that boots it, that creates snapshots and so on, and in fact we have made such a program specifically to deploy MetaPipe onto the CSE cloud. So it's basically just run a few commands in a terminal and get it up and running. However, it's still quite a lot to deal with for the end user. So because of this, we are providing MetaPipe as a service to basically hide all this complexity from the user. This ensures that there are always available resources and that all reference databases and tools are kept up to date. And we are providing currently 2 user interfaces. First of all is the web interface that you can see on the left, which is the one that you will be using during this course. And the second interface is the Galaxy interface that you can see on the right. And the left one is still a bit in beta. It's not publicly available, but it will be available for this course. So I'm going to talk a tiny bit about the MetaPipe architecture and how it's implemented. So this is basically a bird's eye look at how everything puts together. So basically there are three ways that an end user or researcher is able to access MetaPipe. It's through the MetaPipe web application that you see on the left, in which case the user will be able to log in using the Elixir AAI. There is a command line tool, and then there is Galaxy, which would require the end user to log in via the Norwegian NELS IDP. So if the user is affiliated with a Norwegian university, you can just log in there, or otherwise you will have to contact NELS and they will create an account for you so that you can log in to Galaxy. When a job has been submitted through one of these tools, it will be sent to the MetaPipe job service, where it will go to one of the executing backends that actually does the job of running MetaPipe. And for this course, all the stuff will be sent to CSC and run here. So basically, if we take a look at what happens at, if we take a closer look at what happens here, so basically on CSC we have a Spark cluster running. It has a master node, it has a few worker nodes that does the actual computation. All the tools and pipelines and so on are installed on these worker tools. And when the researcher submits a job, it ends up in the job service, it gets sent to the master, which then ensures that the job is executed on the workers. And then we have created a special tool, as I mentioned earlier, which is used to automatically deploy this whole Spark cluster. So basically we have a sysadmin or a developer that is running his tool on the laptop, which will create a virtual machine on cPauta, which will then create the Spark cluster that will run all the jobs. Thank you.